Hello, everybody. I feel like the feedback I got from the review and going over it was good. So I'm going to do some of the homeworks and do the video for some of them, especially the ones that I think might be tricky, so that you don't have to worry about it in class and the in some people in, some people out whole situations. So anyway, here's the homework. And we may have done some of these together in class. We may not have. So I'm going to do them now. I'm going to start with the graphing because that's what we started with learning. So I'll go through those first. So starting with the graphing, solve the following systems by graphing. So for each one, what I'm going to do is graph it by hand. So I always just pick the easiest one first. So y equals x plus 1 means I'm going to have a y-intercept of 1 and a slope of 1, up 1 over 1, up 1 over 1. So I have that line. I'll do this color. And I'm going to do a thin one. So it's a little tough to get the lines perfect. Oh gosh, not that. And I might need to end up moving that because what was so easy in the Desmos was they graphed the lines for us. Graphing them ourselves can be a little bit tricky. Oh gosh, and here I put negative 2x minus 8. I don't even have a negative 8 on here. So this is going to be a little bit trickier, but that's okay. I think I can still do it. So let's say I have a y-intercept of negative 8. So I'm maybe down here for my first point. The slope is negative 2. I definitely don't want to go down because I'm really off of the graph. So instead of going down and to the right, I'm going to go up and to the left. So I'm going to go up 2 over 1, and now I'm on the graph. Up 2 over 1, up 2 over 1, up 2 over 1. So this doesn't intersect yet. I don't see it because I didn't draw the rest of this graph. So I might need to add more points to this or add an extension. So let's see what happens if I continue the slope. So instead of up 1 and over, I'm going to go up and to the left, down, or I'm sorry, down to the left, down to the left. Now I can easily see where these are going to intersect. So I'm going to finish drawing my line, draw one here. Let's press select, and let's make my lines good enough so that they really look like they cross where they should. So I'm going to make this one as precise as I can, and I'm also going to make this one extend so that I can see where they intersect. I'm going to give you lines that always intersect at whole numbers, or I should say integers. So I'm going to make sure we don't have fractions as our answer. So my answer is, I could do a text box or just write it out. I'm at negative 1, 2, 3. So I'm at negative 3 on the x, and I'm down 2 on the y. So that is my answer. If you're still getting your points and your coordinates mixed up, it's time to stop doing that. All right, let's take our next one. So y equals 3x minus 1. So I have a y-intercept of negative 1. And I'm going to go up 3 over 1, up 3 over 1. If I want to get some points in the other direction too, I can always go down 3 over 1. So there's my first line. I'm going to graph it as best as I can. Now I've got the next one. I'll do that in blue. I'm going to have a y-intercept of 6. And I'm going to go down 1 over 2. Oh, easy. Down 1 over 2. I've got the cross happening already. I still want you to graph that line for me so we can really see that these two lines are intersecting. And the point they're intersecting at is 2, 5. Let's go down to 7 and 8. So first I'm going to graph y equals 1/3 x plus 2. So I'll go up to 2 for my y-intercept. And slope is 1/3, up 1 over 3, up 1 over 3, or also down 1 to the left 3. So I have this line. Missed the point a little bit, so I'm just going to adjust that. There we go, that's better. And then I'm going to graph y equals x. Y equals x has a y-intercept of 0 and a slope of 1, up 1 over 1, up 1 over 1. Boom, I see the intersection happen. So let's graph the line. Again, see how I missed the line here? So I'm going to just, whoops, I'm going to go move my line a little bit. So I go through the points. And there we go. I have this point of intersection here at 3, 3. So the solution is 3, 3. Okay, number 8, y equals 2x minus 1. So here's my y-intercept. The slope is 2, up 2 over 1, up 2 over 1, up 2 over 1. So there's my first line. Oh gosh, I keep using colors I don't expect. It's okay. And then I have x equals 3. So what does that look like? That's a vertical line over at x equals 3. So I don't really need to put a point if I don't want to. I can just go graph at x equals 3. There's my line. There's my intersection. So my answer is 3, 5. Okay, now let's go do the ones that don't have graphs. So 1 through 4. So first of all, these are set up perfectly for substitution. They're set up that way because one of them one of them can look however it wants, but the other one, I have it solved for a variable. So in this one, this is solved for y. That means I'm going to take this expression, which is what y equals, and I'm going to plug it in for the y in the other equation. That's the point of substitution. See what's already solved for and put that expression into that variable. So that means I'm going to rewrite this top equation. So I'm going to rewrite 2x, nothing to substitute there, plus 3y. Wait, I don't want to write y. I want to replace y with x minus 3 equals 6. That's the first step of substitution, taking out a variable and plugging something in its place. So x minus 3 is our expression for y. So I'm putting that into where y is in the other equation. Now I have an equation that's easy to solve. It's got only one variable, so I can solve this just like we did in the first couple weeks of school. So 2x plus 3x minus 9 equals 6. Notice I'm distributing. I'm going to run into this problem. That's okay. 5x minus 9 equals 6. Add 9 to both sides. I'm going to have 5x equals 15. Divide both sides by 5, and x equals 3. That's my x value. That is not where I stop. If x equals 3, I also need to find y. In the end, I want a coordinate. I want to know what's the x and what's the y. So if I were to graph it, I would know what point these two things intersect. Just because this is in standard form doesn't mean it's not graphable. So if I could graph these, what point do they intersect at? Well, they intersect when x equals 3. And I'm going to take this 3 and plug it back into either the first equation or the second. It's going to be easiest to plug it back into the second equation because it's just y equals x minus 3. Put the 3 in for x. 3 minus 3 is 0. That's what y is. That is my solution. So all of that work gets me the same thing as if I would have graphed the two equations and found where they intersect. Okay, number 2. For all of these, definitely make sure you start them on your own and then see what, like let's say that just made sense to you. Okay, maybe you can start number 2. But number 2, notice something is a little bit different. My second equation is solved for x. That means that this y minus or y plus 5 has to go in for x. So when I rewrite, I'm going to have 2 times not x, y plus 5 minus 5y equals 1. So I'm substituting. I'm taking out the x, putting in a y plus 5, because that's the other thing that x equals. Now I solve. 2y plus 10 minus 5y equals 1. 2y minus 5y is negative 3y. Subtract 10 from both sides. Negative 3y equals negative 9. Divide both sides by negative 3, y equals 3. That is just one part of the solution. So the solution for number 2 is going to have a y value of 3. But I got to find the x. So take that y and plug it back in to the original. So let's plug it into this one. If y equals 3, x equals 3 plus 5. So x is going to equal 8. That is my solution. Okay, moving on. This one actually is easier, probably easiest, number 3. It says x equals 2. Well, that already means that in my final answer, x is 2. It's 2 all the time. So all we got to do for substitution is plug that in for x. So y is going to equal 1/2 times 2 plus 3. This gets me 1 plus 3, or 4. That's my final answer. All right, last one. Definitely try this on your own. This is what y is solved for, so I'm going to put this in for y. So I'm going to have 4 equals 3x minus 2, not y, putting in x minus 3. Distribute. Be careful, this 2 is negative. So I have 4 equals 3x minus 2x plus 6. 4 equals x plus 6. Subtract 6. We get x equals negative 2. That's just the x value. Go find the y by plugging negative 2 in for x. So negative 2 minus 3 is negative 5. That's my final answer. All right, hopefully you feel pretty good about that.